Okay, so let's interpret what this metal activity lab is telling us. Okay, so here's a typical result. And what exactly does that mean? In this first well, it appears that we have some magnesium ions. That's in the liquid. You can't see them, they're just dispersed in there. Nitrate is in there as well, but nitrate is just a spectator ion, so we don't care about it. Can't have magnesium without a negative ion. But magnesium is the key thing. Magnesium is happy because it has lost its 2 electrons. What metals want to do in life is lose electrons and be oxidized. So magnesium's already been oxidized. Copper is a very grumpy, solid piece right here. It has a 0 charge, it has all its electrons, and it desperately wants to give up its 2 electrons. It wants to reduce somebody. Unfortunately, for copper, magnesium is the wrong person to try to reduce. Notice that nothing happened. So what does that mean? That means that magnesium is more active than copper. All right? Same thing happened here. Zinc ions, copper metal, nothing happened. Therefore, zinc is stronger, is more active than copper. But here in our last of our copper examples, we have silver ions, happy, and copper metal, not happy. But notice the fuzziness that you see there. That fuzziness is very different from the lack of fuzziness. In this case, a reaction has occurred. Copper is active enough to give 1 electron away to silver. Actually, it's going to take 2 silvers to completely satisfy the copper. So the copper will be able to actually dissolve into the solution. Over time, you'll see the solution begin to get blue. As this little woolly worm continues to grow more and more tendrils of what? What is that? That is silver metal. So silver was happy until it receives electrons from copper, and now that fuzziness is actual silver, very unhappy metal. So what does that mean? That means that copper is more active than silver. Okay, so let's scroll down. What else do we have here? We have zinc in magnesium ions. What does that mean? Nothing's happened. And we have zinc in copper ions, and notice a fuzziness. What is that fuzziness? What is forming there? Over here we have zinc. That was a piece of zinc and a bunch of fuzz all over the place because the solution is silver ions. Finally, the hardest one to look at is this one right here. Because magnesium and zinc are very close together on the activity series, what we have here is magnesium, grumpy magnesium. Magnesium that has all its electrons, and zinc ions, which is happy. Who's going to win? Well, the preview came over here. Magnesium was not willing to accept zinc's electrons. That means magnesium is more active than zinc, and the conformation is here as well. Where you see, do you see the discoloration right here? And the fuzziness right there? And the discolor, it's almost like it's rusting. What you're seeing growing on the magnesium metal is zinc 0. Why? Because the magnesium is able to give zinc its 2 electrons, and the magnesium is now dissolving into the solution. So, hopefully that gave you enough clues to be able to interpret the rest. Good luck.